All right, I'm on page 277. Write algebraic expressions. All right. Learn the structure of algebraic expressions. Algebra is the branch of mathematics that uses symbols. A variable is a symbol, usually a letter, used to represent a number. An algebraic expression is a combination of variables, numbers, and at least one operation. For example, the expression n plus 2 represents the phrase the sum of an unknown number and 2. In this case, n is the variable. Any letter can be used as a variable, but the letter x is commonly used. To avoid confusion with x as a multiplication symbol, multiplication is shown in other ways. Division can also be shown in other ways. So here are some examples. 5 times the variable x, you can use 5.x. 5 times x, and notice it's in parentheses. And then you can also have 5 times x, where 5 is directly in front of x. 5 times x divided by 3. Here's some examples. You can do 5x divided by 3, or you can write it as a fraction, 5x divided by 3. 5 times twice the value of x, so 5.2x, 5 parentheses 2x, and 5.2x, which is also the same thing as 10x, because 5 times 2 is 10. I'm on page 278. There's some vocabulary we need to go over. An algebraic expression can contain like terms, coefficients, variables, and constants. When addition or subtraction signs separate the algebraic expression into parts, each part is called a term. Like terms contain the same variables to the same powers. The numerical factor of each term that contains a variable is called the coefficient of the variable, and a term without a variable is called the constant. So let's go ahead and try some examples. Identify the term, like term, coefficients, and the constants in the expression. So the terms in 6n plus 7n plus 4 plus 2n, the terms would be 6n, comma, 7n, comma, we see a 4, comma, 2n. Now it says circle the like terms. Which ones look like each other? The 6n, the 7n, and the 2n look like each other. It says write the coefficients of the terms. That means the numbers in front of the variable. So I see a 6, I see a 7, and I see a 2. And my constant would be my 4. The 4 has no variable attached to it. Okay? Let's go ahead and try another one. So what are the terms in 3x plus 2 plus 10 plus 4x? We see a 3x, we see a 2, we see a 10, and we see a 4x. What are the like terms? The 3x and the 4x are like terms. Also, in this example, the 2 and the 10 are like terms. They're both constants. So my coefficients are the numbers in front of the variables. So I have a 3 and a 4. And my constants would be 2 and 10. To write verbal phrases as algebraic expressions, use the table below. When defining the variable, choose a variable and decide what it represents. Words describe the math problem, the mathematics of the problem. A variable, define a variable to represent the unknown quantity. And the expression, you translate this into words into an algebraic expression. In order to translate a situation to an expression, it is important to correctly identify the operations that are being described in words. Write each phrase below and the operation that it describes. Okay? Hopefully you learned this in elementary school, like key vocabulary words and what operations it means. For example, the product of, product is the answer to multiplication problem. The quotient of, quotient is the answer to a division problem. Increased by, that is addition. the sum of. Sum is the answer to an addition problem. Less than a number would mean subtraction. I'm on 281. All right. Define a variable to represent the unknown in the phrase $10 more than Anthony earned, then write the phrase as an algebraic expression. So they wrote down $10 more than Anthony earned. The variable is D to represent the number of dollars Anthony earned. So the expression would be D plus 10. So the expression D plus 10 can be used to model the phrase $10 more than Anthony earned. That's our turn. Define a variable to represent the unknown of the phrase $12 less than the original price. So that is our words. Our variable, I'm going to use P for original price. Let P represent the original price. Okay. $12 less than. Less than means subtraction. So this could have subtraction in my expression. I'm going to be subtracting 12. So $12 less than the original price. We're going to use P for original price. So our expression is P minus 12. I'm in 282. All right, define a variable to represent the unknown of the phrase 4.5 times the number of gallons. Then write a phrase as an algebraic expression. So 4.5 times the number of gallons. Let G represent the number of gallons. So you could write it two ways, 4.5 G or 4.5 G. So the expression 4.5 G or 4.5 G can be written as a model to phrase 4.5 times the number of gallons. Okay, let's try again. Define a variable to represent the unknown in the phrase 6 times more money than Elliot saved. Then write the phrase as an algebraic expression. So here are my words. Let's figure out what the variable is. I'm going to use M for money. Let M represent the money Elliot saved. Okay. It says 6 times. So I'm going to be multiplying 6 times the money Elliot saved. And we're using an M for the money he saved. So all it is 6 times M. That's it. I'm on page 283. Define a variable to represent the unknown in the phrase. Oops, I'm sorry. I'm on page 282. I skipped this part. My apologies. Write two-step algebraic expressions. Two-step expressions contain two different operations. The table shows how to translate a verbal phrase into an algebraic expression. Describe the mathematics of the problem, and you're going to define a variable, and then you'll translate it into an algebraic expression. So very similar to what we were just doing. So here is a two-step algebraic expression that they modeled for us. Define a variable to represent the unknown in the phrase 5 less than 3 times the number of points. Then write the phrase as an algebraic expression. So 5 less than 3 times the points is the words. For the variable, they're use P to represent the points. So 3P minus 5 is the expression. Let us try. Define a variable to represent the unknown of the phrase 2 less than 1/3 of the points that the Panthers scored. So those are our words. The variable, I'm going to use P for points. So let's P represent the points Panthers scored. Okay, now I need to go back to the words and pay attention to what operations are being used. So it says 2 less than. So that less than means subtraction, so I'm going to be subtracting 2. 1/3 of the points. So I'm going to be multiplying 1/3 of the points, and we're using p to represent the points. So 1/3 times p. So our expression is 1/3 p minus 2. All right, example 5. I'm on page 284. Define a variable to represent the unknown quantity, then write an expression to represent the perimeter of the rectangle. The length of a rectangle is twice the width. This is right here. A rectangle has a length that is twice its width. Let W represent the width of the rectangle. Because the length of the rectangle is twice the width, use the expression 2W to represent the length. All right. So if we're thinking of a rectangle, we're using W for the width, and for the lengths, it is twice the width. So it's going to be 2W plus 2W. It always helps me draw a picture when I think of rectangles. So here's the width, and they said the length is twice the width. So that's what it would look like. Let's go ahead and try one on our own. A rectangle has a length that is 3 times its width. Define a variable to represent the unknown quantity, then write the expression to represent the perimeter of the rectangle. This one's very similar to one we just did. We're to let W represent the width. So it's the same problem, except this time it's going to be 3 times the width. So again, if we have a rectangle, W represents width. So we'll have W plus W, and to figure out the length, it says the length is 3 times the width. So that means it will look like this, 3W and 3W. So to find the perimeter, you add them all together. All right, and that is it.